Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing linear inequalities. This is standard A.2H in the great state of Texas, and we are using item number 25 of the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a student ordering a flower arrangement. We've got roses, we've got carnations, and this is going to be very important here. Does not want to spend more than 30 bucks. Okay, so we're going to need that because this is going to be an inequality rather than an equation. So we got roses for 3 bucks, carnations for 2 bucks, which inequality best represents all possible combinations of X roses. All right, so our roses are going to be X. And our carnations are going to be Y. All right, so doesn't want to spend more than $30. All right, so first thing we need to do is we need to assign the correct coefficients to the correct variables. And you notice here, our two options seem to be 3x and 2y or 2x and 3y. Well, that makes sense because we've got the x's, we've got the y's, we've got the 3 and the 2. Well, what I just underlined in the problem itself is going to kind of give us our idea here. So, roses, $3 each, X roses. So that's as much of a clue as they're going to give you that roses equals X, roses are $3 each. Therefore, if I want to know how much X number of roses cost, right, I'm going to do 3x. Because this 3 is the cost for each rose, and each rose is represented by X. Let's do the same thing for carnations. So carnations are represented by Y. And it also tells us carnations are $2 each. Right there. All right, so $2 each. All right, so that's going to be 2y, because if I want to know how many carnations cost, if it's 4 carnations, 5 carnations, I need to multiply it by 2. Now, you see the only option here is addition, right, if we're looking at our answer selections, but we don't even need the answer selections to tell us that. We're buying roses, we're buying carnations, and it's a combination. So you see that combination, that gives us our clue, that's our operation. All right, so addition. So we're going to add 3x plus 2y, which means let's go ahead and at least eliminate C and D, simply because they have the wrong coefficients. Now the only thing left here is, we've got the 30. What operation are we, or what inequality are we going to represent? Is it going to be less than or equal to? You see these are our two options right here. Well, this is where we have to go back into the problem. We have to kind of insert ourselves into the problem to see what makes the most sense. So, she can choose any combination of roses for her flower arrangement and does not want to spend more than 30. Okay, so does not want to spend more than 30. So let's just see a few options. So if she spends $5, are we good? Yes. If we spend $10, are we good? Put the check mark over there. Yes. What if she spends 15? I'm just doing by fives, right? Because it's one of each. Doesn't necessarily have to keep it that proportional. Yes. 20 is not more than 30. Yes. 25. Yes. Now here's the big question. What about 30? Right? What if she just gets 6 of each and spends 30? Well, does not want to spend more than 30 actually includes 30. So 30 is fine. Now 35 obviously is not good. But when you say you don't want to spend more than 30, that includes 30 as that upper limit, which means it is going to be less than or equal to, and our answer is B.